Hello and welcome to this episode of Math with Martinez. We are in our series in our pre-calculus course where we are discussing problem solving with trigonometric ratios. This is our Unit 7. And in this video today, our third learning goal is to use trigonometry in mathematical and real-world problems, including directional bearing. So I'm going to begin this video by introducing to you all two new terms. That is angles of elevation and angles of depression. So let's go ahead and begin here with these two bullet points and defining just what those things mean. The angle formed by a horizontal line, our horizontal line is going to be this line right here in our figure. It's that horizontal line and the line of sight toward an object above. So our line of sight that is above that object is called an angle of elevation. So that angle of elevation is this angle right here. It is the angle, you could call it theta. It's the angle from that horizontal line when you take your eyes looking just straight ahead and then tilt your head up. That amount that you tilt your chin up and look above is the angle of elevation. Conversely, the angle of depression is going to be the angle that's formed by that horizontal line, which in this case is here. And the line of sight, you see how the person in the little tower is now looking down below. Well, what we're looking at below is the angle of depression. It's marked with orange now. That angle of depression is what happens when you're above an object and take your eyes from looking straight forward and then you tilt your chin down. The amount that you tilt your chin down is that angle of depression that is formed. And with these terms, we are going to see quite a bit of trigonometry playing out in real world problems, because what happens is we actually create these right triangles and we're able to solve for unknown values. You see here with this angle of depression, we actually have a right triangle that we can solve for unknown values with. Or with our angle of elevation, there is also a right triangle that could be formed. So let's look at this example together. From a spot 70 feet from the base of a building, an engineer uses a transit to determine that the angle of elevation to the top of the building measures 67 degrees. If the transit is 5 feet tall, find the height of the building. Okay, so let's go ahead and break this down into pieces. So we need to have, first of all, our little picture, our drawing of this scenario. So I'm going to have some building. Here's the building right over here. This is my building, right? And we have a person that is standing 75 feet away from that place. 75 feet from the base of our building. Where is that? Here is that person. And the 75 feet that they are standing away is denoted right here. That's 75 feet. And they're using a transit, which is this. It says that they're using a transit. That's this little figure here. It's a device used for measuring angles of inclination. And it says that they're using that to determine the angle of elevation. So we're using that to determine that the angle of elevation to the top of our building, so that's this angle right here, is 67 degrees. If the transit itself is 5 feet tall, we're told that this little transit actually is 5 feet off the ground That's this measure right here, this measure from the ground to the point where it was originally our horizontal line, and then it inclines up. That is 5 feet. What we want to do is find the height of our building. So let's talk about how we would do that. Notice that what we have created here is a triangle, a right triangle here with our angle of elevation and then the side of our building. And we're trying to find, we want to know the total height of our building. We know that a portion of our building, right? We know this portion of our building is 5 feet. But what we need to find is this other component right here from the horizontal all the way to the top of the building. We need to find that using our trigonometric ratio. So let's go ahead and begin. How will we do this? Well, we know that we're using this angle. And then we are concerning ourselves with the side that is opposite. This side here is opposite of our angle. We also know this distance right here is 75 feet, and that is the adjacent side. So opposite and adjacent, which trigonometric ratio is going to allow us to solve? Opposite and adjacent. Remember, let's write this down. So, toa. Opposite and adjacent is that last trig ratio, that is tangent. So we will use our tangent function in order to help us find the portion of the height of our building that we are desiring. So let's plug in our values. This tangent of theta, I know the theta, that theta is 67 degrees. The opposite side is what we're trying to find, and the adjacent side is that 75 feet. So if we want to go ahead and solve this, we need only to multiply each side by 75. So 75 times, we're saying 75 times tangent of 67 degrees. And then we'll grab our calculator to figure that out. Let's go ahead and pick that calculator up and type that in. We're going to say 75 times tangent of 67, and that gives us 176 point, it would round up to 7 feet. Now, ladies and gentlemen, that is the measure of our x, but that is not the entire height of our building. We need to make sure to add the, we could call it I height to that, because we are measuring from not the ground, not from the very base of our building, but from a point 5 feet above that. So we need to take 100, we need to add that 5 feet to it. So we're going to take 176.7 and add the 5, and that will give us our total height of our building, which is 181.7 feet. And there you have it. That, my friends, is using our trig ratio in order to solve for the real world problem here, finding the height of this building, which of course we could not do this without a bit of trigonometry. There's no way that we're going to get a measuring tape and like try and measure this building. No, we have to use these devices like this one here and its ability to measure inclination, applying then our right triangle trigonometry to that to find that unknown value. And not forgetting to include this. It would be terrible if we neglected this 5 feet. We would be off a tremendous amount, which as an engineer could be a real issue. So there you go. That is all for this video. If you had any questions, please take a moment to share those now. And until next time, stay fired up.